Hello everyone, welcome to Prakriya Educations. I am Uma Mallikarjuna. In this module, we shall enter into the topics of the second PUC relations and functions and start with the topic types of relations. In this module, we shall learn about reflexive, symmetric, transitive and equivalence relations. The next four relations that we'll be learning now are very important. We also have some of the problems to solve on those relations. Now please check out. The first one is the reflexive relation. A relation R on the set A is said to be a reflexive relation if A, A belong to R for every A which belongs to the set A. Let us have a small example. Consider the set A as, now if I define a relation R1 as, you can recognize that this is nothing but the identity relation which we had already dealt with. Now, if you are looking at the definition, even the reflexive relation consists of the ordered pairs of these kinds, that is A, A belong to R, the same or the like elements inside the ordered pairs. All these elements should be there in the relation in order to become a reflexive relation. And hence you can conclude that R1 is a reflexive relation. Come for the arrow diagram. If I am connecting these elements with respect to the relation R1, then the connection will be 1 to 1, 2 to 2, 3 to 3. This is a simple reflexive relation. Now, if I am writing another relation naming it as R2, is this a reflexive relation? Again, no. This is not a reflexive relation because A consists of 3 elements and all the 3 elements should be related to itself and should be there in the relation. But 3, 3 does not belong to R2 and hence R2 is not a reflexive relation. Now, if in case I am writing another relation R3, now check out, as per the definition, A, A belong to R for every A belongs to A. It means that all elements of A should be of the form or should be related to itself. Now, as per the definition, 1, 1 belongs to R3, 2, also belongs to R3, 3, 3 also belongs to R3. Hence, all the conditions of the definitions is complete. Now, but again, 1, 2 and 2, 3 are the extra elements that we are having in the relation R3. Now, can you consider this as the reflexive relation? Yes, you can consider this as the reflexive relation because I haven't told in the definition that the elements which should be related to itself only, the only term is not there in the reflexive relation and hence even these kind of ordered pairs can be present in the relation and hence you can conclude that the relation R3 is also a reflexive relation and hence the major difference between the identity relation and the reflexive relation is that for the identity relation only the elements should be related to itself and in the reflexive relation all the elements should be related to itself but with extra elements also. Look at the next type of relation, that is symmetric relation. A relation R in a set A is said to be a symmetric relation if, look at the condition, if A1, A2 belongs to R, then A2, A1 also belongs to R. A1, A2, A2, A1, the reverse way. These elements should also belong to R. If this condition is satisfied, only then you can call the relation as a symmetric relation. Let us have a small example. If I am taking the set A as and defining the relation R1 as, okay, let me take an element 1, 2 inside the relation. This relation is not a symmetric relation. Why? Because 1, 2 belongs to R1, but does the reverse order belongs to R1, that is 2, 1. 2, 1, you can check that does not belong to R1, and hence you can conclude that R1 is not a symmetric relation. If I am writing another relation 1, 2, 2, 1. Now, is R2 a symmetric relation? Of course, yes, because 1, 2 belongs to R2, and also the reverse ordered pair, that is 2, 1 also belongs to R2, and therefore you can conclude that R2 is a symmetric relation. If I am writing another relation R3, you can recognize this. This is nothing but the identity relation that we had. Now, is identity relation a symmetric relation also? Of course, yes, because remember that in a set you will not repeat any elements twice. For example, if you are having any set A which is equal to 1, 1, 2, 2. If here you can check that the numbers 1 is repeated twice and 2 also repeated twice, and you can modify this set as, I can write this set as just 1, 2. I am not repeating the elements inside the set. In the similar fashion, even in the relation, you can have 1, 1. Take 1, 1 belongs to R3. You can again pick the same element 1, 1 also belongs to R3. Since the terms or the elements which are there inside the ordered pairs are like elements, you can, if you are reversing the ordered pair, even then you are getting the same ordered pair, and hence you can conclude that every identity relation, I'm stressing that every identity relation is a symmetric relation, and hence you can conclude that the relation R3 is also, yes, it is a symmetric relation. Now, coming for the next example. Now, look at this relation. You can tell that this relation is a reflexive relation because all elements of the set A are related to itself. And hence, as I already told that you can leave these elements for checking that whether the relation is a symmetric one. Now, look at the extra elements that we are having. If you are taking 1, 2, the reverse ordered pair, that is 2, 1 is also present in R4. 1, 2 belongs to R4 and 2, 1 also belongs to R4. No problem with these two elements. Look at the next two elements. 2, 3 belong to R4, and also you can notice that 3, 2 also belongs to R4, and hence you can conclude that even this relation is a symmetric relation. Check for another example. Let me take R5 as. Now, you may notice that only 1, 1 belongs to R5, and hence you can conclude that this relation is not reflexive, but checking for the symmetric one, 1, 2 belongs to R5 and the reverse one, that is 2, 1 also belongs to R5. Hence, you can conclude that this is a symmetric relation but not reflexive relation. Take another example. Now, look at this relation. As you can notice, all the ordered pairs of the form A, A belongs to the relation R6, and hence you can conclude that this relation is a reflexive relation. But coming for the symmetric one, you have got 3, 2 in the relation R6. But you can notice that the vice versa, that is 2, 3 is not in the relation R6, and hence you can conclude that this relation is not symmetric relation but the reflexive relation. You can check R5, R4 is both reflexive and symmetric. R5 is only symmetric but not reflexive. R6 is only reflexive but not symmetric. The next type of relation is the transitive relation. if relation R is defined on the set A and that relation is said to be a transitive relation if, look at the condition, if A1, A2 belongs to R and A2, A3 belongs to R, that implies that A1 and A3 should also belong to R. That is, look at these two ordered pairs, A1, A2, A2, A3. You can notice that these two elements are equal to each other. If such element belong to R, if such elements belongs to R, then the element of the form A1, A3 should also belong to R. This is the condition for the relation to become a transitive relation. Now let us consider some examples. Now look at these relations which I have written. The first relation, that is R1, 1, 2 belongs to R1 and 2, 3 belongs to R1. Notice that these two elements are equal. As per the condition of transitive relation, 1, 3 should also belong to R1, and yes, it belongs to R1, and hence you can conclude that R1 is a transitive relation. Look at the second relation, that is R2. As per the relation, 1, 2 belongs to R2. 2, 3 also belongs to R2. As per our condition, 1, 2 and 2, 3, if it belongs to the relation, 1, 3 should also be in the relation, but it is not present. That is, 1, 3 does not belong to R2, and hence you can conclude that R2 is not a transitive relation. Now coming for the next relation, R3, you can look that this is an identity relation, and this is again a trivial case. Identity relations are always transitive relations, and hence you can conclude that this is, yes, it is a transitive relation. Coming for the next one, that is R4, you can check that 1, 1, 2, 2, 3, 3 are present in R4 and extra elements are also present, and hence this is a reflexive relation, and 1, 2, 2, 1 belongs to R4. 2, 3, 1, 3 belongs to R4. Now, as per the condition of transitive, 1, 2, 2, 1 belongs to R4. As per the condition, 1, 1 should belong to R4, and yes, we do have the element. And this condition, that is 2, 3, you can check over 1, 2 and 2, 3 belongs to the relation R4, and as per the condition, 1, 3 should be in the relation, and yes, 1, 3 belongs to the relation R4. Even 2, 1 and 1, 3 belongs to R4, and 2, 3 is also belonging to R4, and hence you can conclude that R4 is a transitive relation. Coming for the last one, you can check that again you have got a trivial case. Yes, it is a reflexive one, and as per the condition, 1, 2, 2, 3 belongs to R5, therefore 1, 3 should belongs to the relation, and yes, it is in the relation, and hence you can conclude that even R5 is a transitive relation, and also it is a reflexive relation. Also note that all reflexive relations need not be symmetric and transitive. I have also shown you the examples. All symmetric relations need not be reflexive and transitive, and all transitive relations need not be reflexive and symmetric. The last type of the relation, and a very important one, the equivalence relation. A relation R on the set A is said to be equivalence relation only if the relation is reflexive, symmetric and transitive. I have also written some of the examples. Taking the set A as 1, 2, 3, I have defined two relations R1 and R2. Here you can check that 1, 1, 2, 2, 3, 3 belongs to the relation R1, and hence it is reflexive. Now coming for the next one, the symmetric, you have got 3, 2 and 2, 3. 3, 2 belongs to R1 and 2, 3 also belongs to R1, and hence you can conclude that the relation is also a symmetric one. Now, checking for the transitive relation, we have got 3, 2 in the relation, 2, 3 in the relation, and also 3, 3, you can check this, 3, 3 also belongs to the relation R1, and hence you can conclude that this relation is even a transitive relation. Since this relation R1 is all reflexive, symmetric and transitive, you can conclude that R1 is an equivalence relation. Now, look at the next one, that is R2, again an identity relation. I have already told you that identity relation will be a reflexive relation, it will be a symmetric relation and also transitive relation. Since it satisfies all the three relations, you can conclude that any identity relation will be always equivalence relation. In this module, we have covered all the types of relations. In the next module, we shall solve a lot of problems regarding the types of relations. I hope you enjoyed the video. Please don't forget to like, share and subscribe. Thank you.